Okay, any questions? Right. Okay, so now we'll do some more problems involving using in this category using the limit approach. But before we do those problems, I want you to review the logarithm, the basic things about logarithm properties, because we would need to use these things. Okay, so this is kind of math, but if you follow it step by step and make sure you work it out, so you have to write it up, work it out, and practice it don't just come up by just looking at the slide. All right, so let's keep things like using numbers and then look at the formula. So if I have log 8 to the base 2, I can write it as log 2 cubed to the base 2, right? So so I'll write the base outside, and this is 2 cubed 8. So if the base and the base of the exponent, so this 2 is same as this 2, then the answer is just the exponent, which is 3. Okay, so log 2 cubed to the base 2 is 3. So now given log 8 to the base 2 is 3, we can also say this base rise to this answer 3, 2 cube is 8. Okay, so that's what is this kind of formula. If log n to the base b is a, like this, n to the base b is a, then 2 cube is 8, right? So that means the base b rise to this a, 2 cube. So b rise to a is n. So that's the formula. So if log n to the base b is a, implies b rise to a is n. Okay, so for example, if log 2 to the base, say 32, is 5, right? So that implies 2 raised to 5 is 32. Okay, any question?
No.
Good. So continue. Now multiplication, log p times q to the base b, okay, can be evaluated as you split it. So if it's multiplication, it is plus, so you split like this, log p to the base b plus log q to the base b. So an example for that could be something like this. So you have log to the base 2. Let us say I want to evaluate say 16 plus 30, 16 times 32. So I want to evaluate log 16 times 32 to the base 2. You can multiply these two right away and take it to the base 2. But instead of doing that, let us use the log property. So I can split it as log to the base 2, we have 16, log p to the base 2 plus log q to the base 2, which is 32. And in this case, we know log 16 to the base 2 is 4, log 32 to the base 2 is 5, so the answer is 9. Okay, so even if you multiply 16 times 32 and take to the base 2, you are going to get the answer as 9. But this is more simple and straightforward. Similarly, if you have division, log p over q to the base b, then we can evaluate it as log p to the base b minus log q to the base b. So if we have p times q multiplication, the answer is plus when you split. When you have division, p over q is like log p minus log q to the base b. So we can use the same example here. Let us do it like this. We have log to the base root 32 over 16. So how can we do that? We can say log 2 So 32 to the base 2 minus log 16 to the base 2. So that's going to be 5. Log 32 to the base 2 is 5. We just saw it here. Minus log 16 to the base 2 is 4. 2 to the power 4 is 16. So 5 minus 4 is 1. And we can see from here 32 divided by 16, if you do the division right away, 32 divided by 16 is 2, and log 2 to the base 2 is 1, same as this one that we got. So it's a verification of the formula. Now you may wonder how I can find logarithm if my calculator does not have the log to the base 2 function. So far the numbers you worked with are all like what you call perfect exponents or squares of 2, right? So 16, 8, 32, 64 and all these things are perfect squares of 2. So if I have something like say 40, log 40 to the base 2, 40 is not like 2 square or 2 cube, and not like that, right? So it's not a perfect exponent of 2. So how to find logarithm of 40 to the base 2? Now as a rough guess, we know log of 32 to the base 2 is 5, and the next square of 2 is exponent of 2 is 64. Log 64 to the base 2 is 6. So log 40 to the base 2 should be 5 point something, right? So what is that 5 point something? And that's what we need to be able to find. If you think you can do that using a calculator straightforward right away, no. The answer is no, because if you look at a calculator key, you don't have what you call log to the base 2. This log key log is to the base 10, and this ln is to the base e. So these are only 2 log keys your calculators will have. So how to find log of something to the base 2, or in general to any base? Okay, so that's the formula that I have here. If I have log of some n, the base b, some base, any base, then we can either use to the base e log key or the base 10 log key, either one, but we have to stay consistent with it. So if this is a formula, so log n to the base b can be written as log n to the base e divided by log b to the base e. So make sure you use the same base e in both the numerator and denominator. You can also say log n to the base b is log n to the base 10 divided by log b to the base 10. So again use the same base 10. So both will lead you to the same answer. So let us do this problem here. So I can compute, write log 40 to the base 2 as log, let us use base 10. Log 40 to the base 10 divided by, so look at the formula. So it is log n to the base b. So n is our 40, b is our 2. So the formula is log n to the base 10 divided by log b, which is our 2, right, to the base 10. Okay, so all we need to now do is compute these two values. So it's in the log calculator key. So for 40, to the base 10 is 1.6420 divided by log 2 to the base 10, 0.3010. So all you have to do is compute this ratio. It's 5.322. So that's why I said it's 5 point something. Okay. Now you could use the same. You can get the same answer by using the base e. So let us try that. So log 40 to the base 2. Now I am going to use a base e. So log 40 to the base e. So I'll just say log e 40 divided by the base, which is 2. So log 2 to the base e. So again the formula is Log n to the base b is log n to the base e divided by log b to the base e, and that's what I've written here. Okay, so b is 2 and n is 40. So go back to a calculator. So for 40, the natural logarithm is 3.6888. And for 2, log 2 to the base e, which is the natural logarithm, is 0.6931. So just divide one by the other. So 3.688 divided by 6931 is also going to be 5.322. So you get the same answer. Okay. Any questions so far?
No.
Okay. All right. So then we'll look at formulas for differentiation. So you all probably seen differentiation in a calculus class, right? Okay. Now we have just 3 more minutes left. So what I'm going to do is encourage you to go through this differentiation by yourself before you come to next class. So when I go through this in the class next time, it's more easy to understand. So just review your calculus basics of how to differentiate and how to differentiate functions involving logarithms, and then we'll go through it next time and look at these examples. Okay. Alright, so again I suggest reviewing all these things every time. So anytime I finish, go through those things right away.